Hi, my name's Claire Weber. I'm a clinical solution architect with physIQ, and today I'm excited to share how our solution can be used in the cardiorespiratory setting. We'll look at two use cases. First, how physIQ's continuous remote monitoring can detect early signs of decompensation in heart failure patients. And second, how it could potentially revolutionize cardiopulmonary fitness tracking. physIQ's ability to detect early signs of heart failure decompensation starts with our AI-based digital twin model. So let's break that down. To apply this technology, we begin with a 48-hour baselining period. During this time, the system uses advanced algorithms to understand the individual's unique physiology and develop a digital twin of the patient. When baselining is complete, the platform then switches to safety monitoring mode. It uses comparisons to the learned digital twin to watch for physiological changes following a patient's discharge from the hospital. We'll continue to measure that individual's actual physiology in real time, for example, measuring his or her heart rate or respiratory rate at that moment, while at the same time continuously projecting modeled estimates for each of those parameters based on the patient's digital twin. This allows physIQ to make a U-to-U comparison of interactions between ongoing vital sign data and expected personal norms, not population averages. By analyzing the differences between the actual and the expected in one's physiology, we can establish a scaled index that picks up on subtle changes that may be clinically significant for that individual and an early sign of decompensation. This digital twin approach has a wide range of potential applications, one of which is leveraging our multivariate change index for early detection of heart failure exacerbations. Here, we're looking at one participant from our LINK-HF study. Each row indicates the physiological parameters being continuously monitored. We see this individual's heart and respiratory rates, as well as their contextual level of activity at the bottom. We can see both the actuals in blue and the estimates in yellow. This patient was monitored in an observational context, wearing a patch after their initial discharge from the hospital. They were ultimately re-hospitalized 12 days later, as shown by this red line. physIQ's multivariate change index picked up on subtle deviations between the actual and the expected and flagged the risk of decompensation about 7 days ahead of the patient's rehospitalization. With this kind of early detection, care teams can intervene to prevent further decompensation and unnecessary readmissions. Another physIQ innovation is our novel approach to estimating maximum oxygen utilization, or VO2 max, using wearable biosensors and deep neural network technology. physIQ's eVO2 max enables remote assessment at higher frequency and convenience than by in-clinic tests of cardiopulmonary functional capacity, such as the gold standard cardiopulmonary exercise test and the less accurate surrogate 6-minute walk test. Rather than visit a test lab and perform difficult exercise testing, the patient simply wears a small biosensor for several days, and physIQ uses the wirelessly transmitted data to derive a daily VO2 max estimate for clinical remote monitoring. A favorable option for clinical trials, eVO2 max is a passively monitored, objective, and high-fidelity measure of functional capacity that could help diversify patient populations, support decentralized models, and help run faster, more efficient clinical trials. Both the multivariate change index, that indicator of cardiorespiratory decompensation, and the eVO2 max analytic have wide applicability across cardiorespiratory indications such as heart failure, cardiomyopathy, COPD, asthma, and more. Thank you for watching this video. We look forward to continuing the conversation.